My question is, if you are asked what is the value of angle of friction, angle of repose, whenever mu is given, coefficient of friction is given, the answer will be, okay,
10 theta.
10 theta. So mu equal to 10 theta. Nice. That means from that we can find theta, where theta is the angle of friction. Then how angle of repose you can find? Yashraj, how we can find the angle of repose? Yashraj.
Sir, tan theta will be equal to, will also be equal to the angle of repose. Means here theta will be the angle of repose.
Right, right. If we get the value of angle of friction, then that will be the value of angle of repose also. Very good. Okay. Another question I used to ask. Can anyone tell me? Can anybody tell me 3 processes of reducing friction? As we are leaving this chapter, this is the last question we have discussed in the last day, I think. Just tell me what are the 3 processes by which you can reduce friction? Okay, just raise your hands. Okay, 1 person. What are the processes through which we can reduce the friction? Udayan, you tell me quickly.
By giving the substances the oil or grease.
1 process. By using grease or lubricant. Okay, fine. Second one.
Smooth surfaces.
By making the surfaces smooth to smoother. Third one.
By using paints.
What we have just discussed by bevetting process. By using the bevetting process, we can reduce the friction. Isn't it? If we follow the bevetting process is the process through which we can reduce the friction by using alloys instead of direct metal. Direct metal use na kore, instead of that, if we are able to use some particular combination of alloys, then we can reduce the friction, right? Okay, so let me discuss today regarding today's class. There are 2 or 3 numerical that we have to discuss. After that, we will shift the new discussion. That is the second part of the frictional force. Second part of the chapter frictional force, that is the circular motion. So there are a lot of theoretical discussion is there. So let me discuss 2 or 3 numericals first. After that, we will discuss the circular motion part. So numerical on laws of motion. Before that, I have done 3-4 numericals, I think, from this chapter. How many can anyone tell me? What the last number of numerical you have done in the last class? Seven. Okay, thank you. So next, number 8. Question number 8. You pick up the question quickly. Rohit, thank you. The first one, the number 8. Read the question quickly. A body of mass 2 kg starts from rest at x equal to 0 and moves along x-axis under the action of force F equal to kT. Fine. Where t is the time and k equal to 1 Newton per second. Find out the distance travels by the object in 6 seconds. Find out the distance traveled by the object in 6 seconds. So, what are the different data you are given? You have given 2 kg mass, k, the value of the constant is given, time after which you have to find the velocity that. after which you have to find the total distance covered by it. So first of all, what I have to do, this relation has been given. Lokojit, very good. Then wait, let us solve it. F equal to KT. Now, you know, F equal to MA equal to KT. Now, what about A? You can replace the A by unity of V. So dV equal to K by M ddt. Integrating on both sides. Integrating on both sides within the limit. So, what will be the answer? After integration, what will you get? Integration of this will give you the dV. You know K1, mass 2 kg. Integration of T dt. The power of T is 1 actually. This is the limit. Power of T is 1. So it will be 1 plus 1. The same thing you have to write here also. Now what about V? Half. 1, 2 will come before. So velocity equal to 636. So if you are asked to find the velocity after 6 seconds, then you can write in that way. Am I right? Then you can write the following that way. If you are asked how, or what will be the velocity of the object after 6 seconds, then you have to do up to this. But as you are asked to find the distance covered by the object, then what you have to do? If you are asked to find the distance covered, then you should do in that way. V equal K by M. In that case, avoid the limit. V equal to K by M T square by 2. Okay? Now, come in that side. You know, V can be replaced by ddt of x and it will be K by M T square by 2. Right? Now dx equal to K divided by M. K divided by 2M actually. Into T square dt. Now you see, you have dx K by 2M T square dt. In that, whenever you are asked to find the algorithm, very good. You are asked to find the distance covered in 6 seconds, then this expression you have to find out. Now we integrate. Integrate this one. Putting the limit. Value of K 1. 2M. M. The value of M is 2. That is it will be 4. Now it will be T cube by 3. 0 to 6. 1 by 12, I think. It will be 6 into 6 into 6. How much? How much distance? It will be 6, 2 and 18. 18. So, if you are asked to find the velocity, your answer will be up to this. After 6 seconds, if you are, there are actually two questions we have addressed here. What the question has been given written by me. In this, if I introduce another part, that what will be the velocity after 6 seconds? After this, you have to. What will be the distance covered after 6 seconds? That will be the answer. So no need to do this part in that case. If you are asked only to find the distance covered in within the time within 6 seconds, then this part you have to omit. Clear? The answer will be, what should be the answer? Statement of the answer should be, what will be the statement of the answer? Who can? Tell me, anyone, what should be the statement? Saptajyoti. After this, what statement I should write? One statement you have to write. Whenever you have solved the problem, the answer will be the distance covered by the object in 6 seconds is 18 meter. I think it is given in meter. No? It will be 18 meter. Next. Pick up the second question quickly. The second question, this is number 9. It will be number 9. 3 masses, A, B, and C, are as shown. Okay, Shweta, very good. 3 masses, A, B, and C, are shown as in figure. At just one mass A is 4 kg, mass B is 2 kg, and mass C is 1 kg. Fine. You are asked, find out the force in between the contact A and B. Find out the force in between the contact A and B. Okay, Lokojit, fine. Find out the force in between the contact of A and B. So at first, what you have to do? Total mass is 7 kg. So let us find the acceleration first. Okay, Ayan, fine, very good. Write down here acceleration of the system. Here acceleration of the system A equal to acceleration of the system A equal to F by M1 plus M2 plus M3. So it will be 9. You know F 21. M1 1, 2, 4. 3 meter per second square. 3 meter per second square. Now, the force acting between the contact A and B, FAB. That means, as you have 3 masses like this is A, this is B, and this is C. 4, 2, 1. I need this one. In this contact, how much force is acting? Okay, the total force is 21 Newton. Out of that, the mass, whatever the force is acting at the contact of A and B, whatever the force is acting at the contact of A and B will be 21 minus 4 into 3. 4 into 3. Right, very good. Newton. So how much? 12. It will be 8 na? No, 9. How much? It is 9.
9.
So the answer will be 9 Newton. Write down. What should be the statement? Therefore, the force acting between the contact A and B will be 9 Newton. Clear? Now, let us move to the
Sir,
new chapter, new topic. That is
sir এই পার্টটা আবার এক্সপ্লেন করুন।
circular motion. Actually, in circular motion, some topics are there related to friction. That's why we'll try to complete the total discussion related to friction. What the total topics are there related to friction, we'll try to finish within the chapter of friction. Okay, the first question, read out. What is angular displacement? What is angular displacement? Right, it's unit and dimension. Listen. If an object is moving in a straight line, gradually with respect to time, it will travel a distance. It may be a distance covered. If you consider displacement, you can measure also the displacement covered by the object. Now, whenever an object is moving in a circular or a curvilinear path, always it is not possible that every object will move in the straight line. There may be some motion having a particular curvature. In that case, if you consider an object is moving in this way, I am considering very simple motion. Instead of rectilinear propagation, we are considering a curved path followed by the object. If an object is moving along a circular path, say the position of the object is here, after time t, it reaches the point B. So the initial and final position of the object, whenever connect with the origin of the circle, then they will produce an angle. That angle in between the initial and final position of the object, initial and final position of the object is termed as angular displacement. So if in time t, if the object travels from point A to point B, making an angular displacement and making an angle at the center of the circular path, that angle is called angular displacement. So how we can define angular displacement? Angular displacement is the angle. Angular displacement of the angle made by the initial and final position of the object at the center of a circular path. Angular displacement of an object is the angle produced by the initial and final position of the object subtended at the center of the circular path. So, as you know, if radius is r and this arc can be considered as s, then angle theta equal to arc by radius. Arc we can denote in that way, arc by radius. This is the distance, this is also distance, this meter, so it should not have any kind of unit. So it is unitless. ঠিক আছে কিভাবে লিখবো ইউনিটলেস লিখবো অ্যাঙ্গেল আছে ইউনিটলেস লিখবো না আমরা অ্যাঙ্গেলটাকে লিখি ডিগ্রি অথবা ভেরি গুড রেডিয়ান আর যদি বলে ডাইমেনশন কি লিখবো what should be the dimension? It will be dimensionless. So here we are getting a special information. Some quantities are there, some physical quantities are there, those have unit but no dimension. Angular displacement is one of them. Angular displacement is one of them. It has unit but no dimension. Okay, so if you are asked, give an example of a physical quantity having unit but no dimension, then angular displacement will be there. And angular displacement will be this. So many examples of this. Just now, what about angular displacement? Rather, unit and dimension, it's clear, I think. Now, second question, quickly. What is angular velocity? Quickly, write down. What is angular velocity? Write its unit and dimension. What is angular velocity? Write its unit and dimension. Now, as you know, that the object is moving in the circular path of radius small r, and in time t, it changes its position from A to B. In time t, it changes its position from A to B, making or subtend an angle theta at the center of the circular path. At the center of the circle, during its motion along a circular path, definitely it should have a particular velocity. That velocity is termed as angular velocity. In case of translatory motion, in case of rectilinear propagation, we have considered linear velocity. Now, as the object is moving in the circular path, we cannot consider as a linear its velocity as the linear velocity, though we can convert it into linear velocity. But if you are asked what is angular velocity, what should be the definition? Definition is the rate of change of angular displacement. Rate of change of angular displacement is called angular velocity. Then after that, you have to draw a diagram like this. If an object travels from A to B along a circular path of radius small r, subtending an angular displacement theta at the center of the circle in time t, then angular velocity omega equal to theta by t. Then angular velocity omega equal to theta by t. Now, problem is that if it changing its velocity continuously, then what will happen? Then we will consider different types of velocity: instantaneous velocity, average velocity. There are so many types of velocities are there. We'll discuss it later on. Just write down what is the angular velocity. The rate of change of angular displacement is called angular velocity. What is the unit of it? It is radian per second. What is the dimension? Now tell me anyone, what is the dimension? Its dimension is t to the power minus 1. T to the power minus 1. Right. M0, L0 to the power minus 1. Can anybody tell me about having the same dimension like this?
The frequency.
Raviraj,
Frequency.
another one.
Uh,
Who can? I know your answer will be frequency. Very quickly you can answer it. But another one. No one can. No one can. Very bad.
Sir,
Another is
angular frequency.
angular frequency. Actually, frequency, angular frequency, this one. Huh?
So velocity gradient.
Angular frequency.
the power.
Velocity gradient. Yes. Velocity gradient. What only?
So Dipankar Saha.
Okay. No, not power. Actually, velocity gradient. You see, this is actually called velocity gradient. With respect to the distance, if the velocity changes, that ratio is called velocity gradient. It has also the unit T inverse. Frequency T inverse, velocity gradient T inverse. Right? Very good. কে বলেছিল এটা velocity gradient টা?
So Dipankar Saha.
Very good. Dipankar কিন্তু পড়াশোনা করছে deeply. Next. So this is the all about the angular velocity, unit and dimension. Now, and what is number 3? What is angular acceleration? What is angular acceleration? What is angular acceleration? Write its unit in dimension. Okay. What is angular acceleration? Write its unit in dimension. Now, as just a few minutes before I have discussed, if an object is moving in a circular path having different velocities at different time in the instant of time, then how we can measure the velocity? Then in that case, we have to consider instantaneous velocity. What the velocity of the object at that moment? That velocity I have to measure. Now, if the velocity continuously changes, how we can consider? Can anyone tell me if the velocity changes continuously as well, how you can measure the velocity at that moment? What is the procedure? We have to measure average velocity. Okay, or we can give an idea about the motion of the object by calculating its acceleration. If we can get an idea about the acceleration, then we are also able to explain the nature of the motion. Am I right? Now, question is that if object changes its velocity continuously, then acceleration will the object will have an acceleration and we can measure the acceleration. How? Say, when the object starts from A having angular velocity omega 1 and it reaches the point B having angular velocity omega 2. Okay. If in time t it reaches from point A to B, then angular acceleration of the object A equal rate of change of angular velocity. Rate of change of angular velocity will give you the angular acceleration. Then what is angular acceleration? Angular acceleration is the rate of change of angular velocity. Okay, and after that you have to draw a figure and write the language. What the language you should write? Consider an object is moving from point A, moving along a circular path of radius smaller. At point A, its velocity was omega 1. After time t, it reaches the point B having angular velocity omega 2. Therefore, angular acceleration of the object A equal to omega 2 minus omega 1 by t. Therefore, what should be the unit? Can anyone tell me what should be the unit? What should be the unit? Ananya, Dhritiman, Ayush.
Radian per second square.
Radian per second square. And what should be the dimension?
T to the power minus 2.
T to the power minus 2.
T to the power minus 2. Very good. T to the power minus 2. So this is the dimension. So we come to know about angular acceleration and its unit and dimension. Now, question number 4. The last question we will discuss today. Establish the relation between angular displacement and linear displacement. Establish the relation between angular displacement and linear displacement. Just listen. If you have an object moving along a circular path radius smaller, and this is the arc. AB is the arc which it covers in time t, making an angular displacement theta at the center of the circle. In that case, if you are asked what is the relation between angular and linear displacement, just few minutes before, very good. Few minutes before we have discussed, if the arc is S, small r is the radius of the circular path, then angle subtended at the center theta equal to arc by radius. Now, if you know the linear distance, then you can find the angular displacement. If you know angular displacement, then you can also convert that angular displacement into the linear displacement. Say the position of a star or satellite is continuously changes in the sky. When we are observing this, at that moment, this position is this one. And after 1 hour, its position becomes this one. So what is the angular displacement of the position of the star, of the position of the planet? In that way, we can also find how much distance that planet or that satellite has been traveled. If we come to know about the distance, if we come to know the circular path along which the satellite is moving, and angular displacement, if we are able to measure, then we can make a comment about the total distance traveled by the satellite or maybe star. So these relations can also be applicable during that calculation also. Next, number 5. Actually, this is not the main target what I am trying to do now. The relation between the angular and linear velocity. This is very important. That I will try to prove it. How you can establish the relation between angular and linear velocity. In this case, you have to mention some particular theoretical lines. You must write the total scenario, what the procedure you are going to do, the background phenomenon you have to write in language. Maximum time what I have observed, maximum students are doing the calculations without any language. But in physics, you must write the language first, prepare the background of the phenomenon. After that, you should do the calculation part. So what should you write? Consider a particle is moving along a circular path of radius smaller with angular velocity omega. Stop. In time t, the particle travels from point A to point B such that the arc AB equal to S, and angular displacement AOB equal to theta.
স্যার এই লাইনটা আবার বলেন না ইন টাইম টি
Therefore, angular displacement theta equal to angular velocity theta equal to omega equal to angular velocity omega equal to theta by t. Then theta can be replaced by S by R, as just a few minutes before we have discussed it. Omega equal to S by R into 1 by t. Therefore, omega equal to S by t into 1 by R. You know, S by t, it is the linear velocity, right? V by R. So what about V? It is omega R. This is omega R. Okay. So this is the relation between linear and angular velocity. So if you are asked to establish the relation between the linear and angular velocity, first of all you write the language. After that you should derive it. Now in vector form, what should I write? Anyone can tell me? Anyone?
To R cross omega.
Is it V equal to Argodip? You just tell me, what should I write in vector form? Vector V equal to, after that, in vector form, vector V equal to R cross omega. Is
Sir,
it
omega.
Shorodip? R cross omega or omega cross R? Which one?
Sir, omega cross R.
Omega cross R, right. It will be omega cross R. Clear? So these are the today's discussion. What I have done today from the beginning. We have done two numericals regarding laws of motion. After that, the circular motion, the chapter we have started today. You just prepare the total note. Omega cross R. We have done omega cross R. Regarding circular motion, just I think all of you should prepare a copy, and in that copy, what are the topic we have discussed? What is angular displacement? What is angular motion? Angular velocity relation between these. Gradually, you have to prepare the note. Okay, as I have told earlier, that all of you should write what I am doing, what the numericals we are doing in the classes, all the questions, all the theoretical part, numerical part, you have to prepare in a particular copy and preserve it. Whenever we will ask to submit it in the school, not only my class, other physics classes also we have to provide. Okay. ঠিক আছে, অতটুকু থাক আজকে, ঠিক আছে? Any other question from your side from today's regarding today's discussion? তাহলে জিজ্ঞেস করতে পারো. Is there any query regarding today's class? Last numerical. Okay, Dipankar is asking the last numerical how we have done. Actually, in that last numerical we have three objects. If you are pulling the first object, with the first object the other two objects are also attached, then the three objects will move. So your force is 21 Newton and the total mass is 7 kg. Then in that from that information you can find the acceleration. Now, as you are asked to find the force between the objects A and B, That means what? What the force is acting? What the force is acting in the junction of A and B? Total force is 21. Total force is 21. And the acceleration was, I think, 3. Then if you are asked to find the force between A and B, then how much force is acting on the remaining masses, that is on the 1 and 2 together, that a value of force you have to find. So how much force is acting on 4? 21 is the total force. How much force is acting on 4 kg? It will be 4 into 3. That is 12 Newton force is acting on 4 kg. And the remaining force, 21 minus 12, is acting on the masses of 1 and 2 kg together. So just we have subtracted 12 from 21. Okay. Any other question? Let me take the attendance today. Wait. Any other question from your side? আর কিছু আছে জিজ্ঞেস করার?
No, sir.
Okay. Now, Oviraj. Just Oviraj আর দেখি Ananya. Just I am asking one question to both of you. देखी के पारे. Last question. What is the angle between the linear velocity and angular velocity? As you come to know, both of them are vector quantities. What is the angle between the linear and angular velocity? Aviraj, Ananya, okay.
So 90 degree. So 90 degree.
90. How we can realize it is 90?
So because omega, so sine 90 is 1. So one is tangentially and one is in the center.
Actually, whenever any quantity is obtained, through the cross product of two quantities, then the resultant will be always perpendicular to both of them. Isn't it? We are getting V through the cross product of omega and R. So V must be perpendicular to omega, V must be perpendicular to R. Clear? Is it clear to everyone? বোঝা গেল? এটা মনে রাখবে। Okay, very good. তো যখনই A cross B করে আমি C পাবো, in that case C is perpendicular to B, C is perpendicular to A. Okay? So এতটুকু থাক আজকে। Next day, the remaining part of the supplementation we will discuss. So thank you for today. ঠিক আছে? রাখছি তাহলে আজকে।
Thank you, sir.